Hi YouTube, this is a walkthrough of an easy Try Hack Me room available to subscribers from an author Heaven Reza. The room focuses on Osquery, a tool used to explore operating system data by using SQL queries. 10 tasks, let's jump right into it. Introduction. Osquery is an open source tool created by Facebook. I will focus on hands-on part and rely that you will read all the instructions on your own. This task needs no answer. So let's proceed to task number 2, installation. The virtual machine attached to this room already has Osquery installed and configured for you on Windows and Linux. So let's start the machine. And while the machine is initializing, okay, no answers needed. We'll get a feel of the upcoming tasks. So task number 3, interacting with Osquery shell. So this task relies on a machine already running and that we have an access to the command line and PowerShell. So let's get a feel of the mentioned resources in this room's instructions. So GitHub for Osquery. What is Osquery? Osquery exposes an operating system as a high-performance relational database. This allows you to write SQL-based queries to explore operating system data. Meta's resources for Osquery. Alien Vault, go threat hunting on your endpoints. Cisco Orbital. And if you're not familiar with SQLite, here is one of the mentioned resources for learning. And don't be threatened if you're not familiar. Dedicate a few hours to it and hop back to this room. There's a lot of free resources available to learn it, but I think that this room, as an easy room, does not need you to be an expert on SQL, and room's instructions are enough to finish this room. So Osquery for log aggregation. Also, you can read syslog with Osquery. And okay, machine is initialized. Okay, waiting for the taskbar, and okay, we have their command line icon available. So we have to answer some questions in its tasks. To find Osquery version, SQLite version, default output mode of Osquery. Okay, we have an output, terminal output of Osquery. Let's run the meta command .help, and we can already see some answers here. So we can get the default output mode. Mentioned here is pretty. Meta command to set the output to show one value per line is a mode line meta command. And two meta commands to exit Osquery are .exit and .quit. From the meta command .summary, as we see here, we can get an answers for first two questions, but also the meta command .show shows the same answers, Osquery version and SQLite version. Next task, task 4, schema documentation. Head over to schema documentation here. Read the tasks instructions on your own. And let's focus on answering the task's question. So what table would you query to get a version of Osquery installed on the Windows endpoints? Let's see what tables we have available with meta command .tables. And the answer here would be Osquery lower line info. Let's see what we have there available. So let's select all from Osquery info, and a must for Osquery one-liner commands is a semicolon at the end of the line. Okay, we have here prettified output. Let's see the output in multi-line. Okay, and we can get a version. We can see more clearly, I think, version from this mode line. Output version is 4.6.0.2, and select on just to see only as an output just versions. We will use command select version, not star, but select version from Osquery info and semicolon at the end of the line, and we see the one-liner output which shows version. So we'll focus here on this version. We can select 460 as version and see the number of tables available for Linux, available for Windows, and the first table that is in common for Linux and Windows is ARP cache. So we answer these questions. And proceed with task 5, creating queries. SQL language implemented is Osquery. In Osquery is not an entire SQL language that you might be accustomed to, but rather it's a superset of SQLites. Imperative is a semicolon in one-liners. In regular Osquery commands, so let's focus on answering the question. What is the query? To show the username field from the users table where the username is 3 characters long and ends with an N. Use single quotes in your answer. We will first see one superset of commands available from the table users. And we see we have a UID, GID, UID signed, GID signed, username description, directory, shell, UID, and type. And we have to select a username which is 3 characters long, ends with an N. So that leaves one character available as a wildcard. And we must use a lower line. So the answer would be select username from users where username like. Single quota, lower line, and single quota and semicolon. So we do not have any output. None of the usernames suits this request. Next task focuses on using Collide Fleet. We will look at an open source Osquery Fleet Manager known as Collide Fleet. Okay, the attached VM has Collide Fleet installed and configured thanks to the Windows subsystem for Linux. Steps needed to be executed to start Collide Fleet in the attached VM. Okay. Let's proceed to the Windows subsystem for Linux. Okay, we have some questions here, and we have to find the Osquery role secret. So that realize we already installed the Collide Fleet server, management server, and its graphical user interface. So these are some of the mentioned resources for Collide Fleet. But as mentioned, the Fleet is already installed in the tag box, and we'll use that. So open the Ubuntu terminal. And let's try to copy paste the Collide commands available in this text file. So as usual, I have more or less luck with copy pasting these commands. And let's just fast forward this part. Okay, let's try and let's manually type in the first short command, but hopefully we won't have to type manually this longer command that awaits us. Second command, try to copy paste this part. Now again we will type the command manually. Okay, starting the MySQL database server. And let's proceed to the third command. Third time is a charm. And let's try to copy paste the command from the text file. And we successfully pasted this long command. Let's run it. Okay, looks good now. Let's try to open Google Chrome and navigate to the mentioned address. Home and the port 8080 with the mentioned credentials. And we will have to add the host machine. We will have to open a command line and launch this launcher command mentioned in the textual file. Okay, your connection is not private. We'll proceed. And use provided credentials. Login. Login successful. Okay, no matching hosts needed. So we have a server running. Let's set up the clients. So to add the new host, we have available a Osquery role secret for the host. Let's show it, and let's paste this secret into the question in this task. And to set up the client, we paste the command. Also, we prepare the command run the command line. We'll quit the existing Osquery Interactive and go to the mentioned directory, and from there run the launcher. Let's try again to copy paste the command from the text file. And we successfully pasted the command with the role secret for this client. And let's run the command. Looking good so far. As it all goes well, you should see the command successfully added to the fleet. Let's reload this page. Okay, nothing new for now. We have a new 0, online 0, offline 0, MIA 0. So let's try to run to reload the page again. No, nothing. Let's try to run the launcher again. We'll wait a bit longer than we did the previous time. We get some errors, but let's try to see if we reload the page. We reload the page, will we see a new host showing? Okay, new 1, online 1, incoming host. So it seems it will be a good result. We have a host incoming. So let's get an overview of the task. As I mentioned, I expect you to read all the room's instructions on your own. Let's reload the page once again. Oh no, this doesn't look good. We have an offline host. So the red line we have now, before it was green, but now something looks like it went wrong in the meantime. But let's wait a bit. Let's stop this command here, and let's try to run the command once again. To refresh, we'll close this command line, reload the complete fleet, graphical user interface. Okay, but wait a minute, we have here host showing, but okay, let's see what will happen. Let's ignore the part where we close the command line. Let's try to run this query to see if it will provide some results. No results found, which is weird. It should show the Osquery info. We will run the launcher command once again. And see if that will bring the host online this time. So far looks good. We know the host is online, so we expect to see it as green colored. So let's reload the page. And okay, now it's green, online, new, looks good. Let's try to use this query. Let's call the query THM query. Okay, selected target, and let's run the query. Okay, great. We have results from that query, and we have to answer what is the Osquery version. And as seen from Collid Fleet, we have a version 4.2.0, and we have to find the path for the running process. So we'll need to query table processes and to find running Osquery d dot exe process. Great, we have an output, and let's find the column path and see what we have there and use that as answer. Let's filter the path column, and we need Osquery d. Let's scroll to the correct point. And we have a correct answer here. C users administrator desktop launcher Windows Osquery d.exe. And with that, we answered all questions from task 6. Task 7, Osquery extensions. So extensions add functionality features, additional tables that are not included in the core Osquery. We have 2 repos for Osquery extensions mentioned, and we have to answer the shown question, which focuses on one of the mentioned extensions, Polylogy X, and what it does. At this time, we have 25 features here mentioned that add functionality to the original Osquery. And the mentioned tables that go with this extension. But if you try answer 25, at the time when the room was built and edited, the correct answer was 23, so less functionalities this extension had at the time. And let's continue the task 8, Linux and Osquery. We will need the Ubuntu terminal and from there to launch Osquery and to answer these questions. So let's stop the Collid Fleet graphical user interface, so we won't be needing it anymore. So here we have available Windows subsystem for Linux, and we'll there run the Osquery interactive Osquery I command to get the Osquery terminal. We'll use Yara in this task, review the on-demand Yara scanning here to answer some of the questions below. So the Yara resource is here attached. Let's try to run Osquery command again. So we need to see the specific Osquery. Yeah, this one sign for the Osquery terminal, Osquery, and pointy bracket pointing to the right. So let's run the meta command .tables to see if we have what tables do we have available. Okay, we have these tables available, and for the first question, what is the current value for kernel OS release? We'll try to use this command, select all from kernel, lower line, info, and not to forget the semicolon at the end of this one-liner. Okay, let's see it with the mode line. Okay, we here see the version, and we'll type that as the answer. Next question, let's select all from users, where username equals, so we know the full username. We don't need any wildcard characters, so we can use the equal sign, and equal to user of the interest is Bravo. And let's type the UID for the Bravo user. Next question focuses on binary padding attack, and the question is, what was the target file in the attack? So we have to research here what are characteristics of the binary padding attack and what is the target file. So we can see the Osquery schema. For this version of Osquery, it has an available file table. It is possible to query paths, for example, A time, M time, C time. And one of the useful resources I found is from the Red Canary Atomic Red team. We have here the description of this attack and commands specific for this attack. Also here from Red Team Notes 2.0, defense evasion, obfuscated files or information, binary padding. So we have the description of the attack and how we can find the specifics of this attack, focusing on file attributes, modification time, and access time. So let's use what we've found to get the answer of this question. So we'll try to search for a file where path can be anything. And access time is different than modified time. So that's one of the specifics of the attack. Okay, we have some answers here. So let's we don't need anything, we don't need all the results showing, but let's focus on file name and the path. Okay, we have here mentioned fleet.zip, notsus, and server.key. Okay, let's see. Yeah, we notice that for all of these for all of these results, UID is 100. So what we can do, we can filter from users and filter for specific UID of 100 to attach these results, these files. We come up to the correct user. Okay, when we search all users, we have more than this one with UID 100. So let's filter and select from users where UID 1000. Okay, that's UID 1000, and his username is tryhackme. We see here his directory and which shell he uses. We know which user maps to this file. Let's see if we can filter one of the results from the shell history of this user. So we have available shell history table. Okay, let's do some more filtering. So we want to see just commands. We are not interested in one of the rest, like time and history file. So let's run the select command from shell history where UID equals to this tryhackme user. And okay, let's see from his shell history. We have mentioned the command which we saw is specific for the binary attack, binary padding attack. Okay, and we see here the file name, and we will use that as the answer, which is correct, notsus. Additionally, we could use mode pretty to see SQL-friendly output. Let's run the same command once again, but we can also limit the result, for example, just to see only 10 last 10 commands from this user's shell history. Okay, we see the same command available here, and we can go back to the mod line. Next question focuses on the hash value for this file. So we can find this answer in a couple of ways. We can exit the Osquery terminal, and from the bin bash shell, we can try to get the MD5 sum of this file, and that we will try first. So we will open a new Ubuntu terminal, and let's print working directory. Okay, we were in the right directory, LSL, and we have the file available in front of us. Let's see the MD5 sum command of the notsus file. and we can use that as a hash. That is a correct answer. But also what we can, this is unrelated to Osquery way of finding this answer to this question, but in Osquery we can double check from the Osquery schema for this version of Osquery what tables do we related to hashing do we have available. Okay, we have a hash table and we have there available MD5 command, so let's try with that and select all from hash limit 1 to see one set of available commands. Okay, we have to do a bit, we have to add the where here, so let's add additional condition. Let's try to select all from hash where path like can be anything, so we have multiple wildcard characters and limit to 1. So we have here something mentioned, cannot read file that exceeds that exceeds size limit fleet zip. Okay, we know that that the file that we are looking for is Notsus. So and as we know that his home director, that this file is in directory home / try hack me, we will try to give a more specific command as select path MD5 from hash where path equals to home try hack me Notsus. And we forgot the semicolon, so let's run the same command but with semicolon. Okay, that gives us back to our Osquery terminal, and run the command with semicolon. Okay, we have the answer here that shows path and MD5 hash, and that's also that's the correct answer here. We can use that. And next question is check all file hashes in the home directory for each user. So we saw that we have multiple users available. One file will not show any hashes. Which file is that? So let's try with select path MD5 from hash where path like home / %sign for multiple wildcard characters, and MD5 can be is not shown, so we'll use two single quotas and nothing in between them, and important not to forget semicolon at the end, so we don't have anything as an output. Okay, let's try because we are searching for a file in this home directory. So let's try to use 2% . And we have an answer here. So because we are using a specific file, we are not searching for a directory, we have to use home / %sign for the username, can be anything, and / once again the %sign for the file name, can be anything. And that gave us the correct answer, fleet.zip. And the next question it focuses on a malicious file in one of the home directories. We have to query Yara table here. Okay, we have a Yara table available, and use the sig file which is saved in the mentioned directory under this scanner.yara name. Which file is it? So we have to find the malicious file, and let's select all from Yara. Okay, we are missing the where clause. Let's try to add it. Let's try to add the where path like home %sign, and limit to 1 to see what set of commands we have available. Okay, we still do not have a significant output. Let's double check the mentioned attached Yara page. To get a feel for what we might be missing. And let's scroll through the page. I recommend you do all the reading of the attached resources on your own. Okay, let's try with this command. So to add a path and to add a SIG file. To mention the SIG file. So let's select all from Yara. Like previously, path like. We don't have the exact path, but we use wildcard characters, so we use not equal sign, but like. And the SIG file, mentioned SIG file under the quota signs, single quota signs. Okay, we have an output showing. We can try to if the meta command dot mode pretty will be more friendly for us. Let's run the same command again. Okay, we see the notes. File shows 2 counts, ACAR AV test and ACAR substring test. We have 2 matches, path of the notes file, matches count, SIG group, SIG file, strings, tags. And you will use the mentioned matches as the answer to the question in this room's task. Let's go back to mode line and see for the previous file notsus what are the string matches. We see it already from the upper SQL query, SQL friendly table. But let's try to run this more specific command in mode line to see if we will again receive the correct answer. Okay, this is for the notes, but for the question 3, we can see a correct answer for the string matches in the table, but we will run in the line mode line the specific command. and we received the correct answer. Icar substring 1b. Next task focuses on Windows and Osquery. Using Osquery from the command line or PowerShell, we'll use PowerShell in this task. Previously, we used Osquery from command line. We tried the Osquery from the Windows subsystem for Linux, and now let's try to use it from the PowerShell. When the PowerShell loads, we have to run the mentioned command in the room's instructions to load the extension. We wait for the command prompt to reflect the praise done start driver and answer the shown questions here. First question, what is the description for the Windows Defender service? PowerShell is taking a bit. Okay, we have it. We have the PowerShell running, so let's try to load the extension. Let's type the command manually this time. Osquery allow unsafe extension, location of the extension and the name of the extension itself. Let's fast forward this part. Okay, let's run the command. Okay, we see Osquery terminal. You expect to see these tables available with the Polylogy X extension. Okay, we have the done start driver showing. Let's enter. Okay, Osquery looks great. Let's switch immediately to mode line and see what tables do we have available. Great, we have those tables showing in the GitHub repo here also. And let's try to answer the first question to find the description for the Windows Defender service. So we have a service, and let's try to select all from services and limit to one to see one set of command available from this services table. Okay, we see the available set of commands such as name, display name, path, and description. Let's filter that. So we are looking for a Windows Defender service, so we can presume that the name will have the characters def inside of it. So let's add where name like quota, %, def, %, quota, and semicolon, and we have an output. Okay, we can do some more filtering from that, and we need only the let's filter display name and description. We are doing this filtering just for clarity. Okay, we have two outputs showing display name optimized drives, and the second display name Windows Defender antivirus service. So that's the second one that will be correct, and we need its description. We type it in, and that's the correct answer. Next question, there is another security agent on the Windows endpoint. What is the name of this agent? Basically here we are looking for a program. So we will select all from programs and limit one to see one set of commands available with this programs table. And we'll try to find this agent from its name, for example. And let's see names of all installed programs. And from there, we should recognize the correct answer as Alien Vault agent as a security agent. Next question, what is required with table win event log data? So let's try to see that. Select all from win event log data and limit to one, because we can have multiple results and we just want to see one set of available commands. So let's just limit to one set of commands output. Okay, we see here output mentioning source. Provide source as input in query. Use this helpful table win event log channels. So let's try to select all from win event log channels. We see here we have only source mentioning, and that is the correct answer. Source is required with this table. So next question focuses on the count. How many sources are returned for win event log channels? So let's count them. Count all sources with the command select count and in bracket and in parentheses is a star. So select count them all from win event log channels, and the correct answer is 1076. So next we need a schema for win event log data, and the command for that we'll look it up in the meta command help with .help, and we see there mentioning .schema and the name of the table we have to add. So we'll do that and see the output. The output be typed in as the answer. Okay, with meta commands we don't need the semicolon, and great, when we type the command without a semicolon for this meta command, we received an output and we type that in. That's the correct answer. Next question, the previous file scanned on the Linux endpoint with Yara is on the Windows endpoint. What date time was this file first detected? And we have here answer format and hint. We'll use this hint, which points us to the docs Microsoft page. Review event logs and error codes to troubleshoot issues with Microsoft Windows Defender. And okay, we had with Yara, we are basically we scanned for malicious files, and we are trying to we'll use the event IDs for the malware detected. And if we search for malware detected, we receive two event IDs, 1006 and 1116. So we will use those when filtering. So the previous file scanned on Linux endpoint with Yara is here, and we know it's malicious. So we searched for malware detected and received two possible results, two event and two event. With those, we have two event IDs, and we'll use those. So select all from win event log data, limit one. Okay, yeah, we forgot to add the provide the resource. So let's try to select all from WinEvent log channels that previously we saw a helpful table where source like def. So with Windows Defender we detected that file, and as an event ID should be 1006 or it should be 1116. Let's see what we will get with that filter and move from there. So we're trying to find the full name for the Microsoft Windows Defender. But we have to use the correct table and correct name for the source. Okay, it doesn't allow us to query the data table, and we will try to look more deeper where are we making the mistake. Do you see where I made the mistake and why we do not receive the correct output? I forgot the percent sign. So when I added the percent sign, we have an output showing. Great. So from here we can see the full name of the source as Microsoft dash Windows Defender slash operational is the full name of the source, and we have to use the full name of the source to be able to use to query the table WinEvent log data. And this is the part where I fat fingered the try hack me tab and accidentally closed it. So yeah, so let's open the try hack me room again and hope for the best. This Osquery room you can find in search Osquery, also as a part of the cyber defense path. And we are once again in this Osquery room. Okay, great. We have our PowerShell and all commands back. Room is running. Great. Let's continue. So we have to add the correct source name. Oh, great. We have several output showings, but looks like we are on the right track. Let's just limit to one. Okay, we have here a superset of available commands. And let's focus on event ID, date time, and add the correct event ID. So we can we presume the event ID should be 1006 or 1116. And let's add that to our previous command and extract that limit one. So select event ID and date time. We only want to see those two outputs from this table where source is Microsoft Windows Defender and event ID is one or the other. So okay, great. We have the two outputs showing with the same event ID 1116. We don't have the other one event ID we mentioned. So we'll focus on this event ID 1116 and we have here date time. So the question was what date time was this file first detected? So we'll use the first of the two dates in the correct format. Next question focuses on sysmon event. So similar to the previous query we used, but not for the Windows Defender, but for the sysmon. So we have to use the correct source name, full source name of the sysmon. We will at first query, to find that, we will at first query the WinEvent log channels table with the select all from WinEvent log channels where source like we can presume sysmon. It has sysmon in its name, and we will use a wildcard, multiple wildcard characters before and after sysmon, and we immediately receive the correct answer. Source is Microsoft Windows sysmon operational. And we will use that to query the log data table. So select all from WinEvent log data where source equals. So we can now, when we know the exact the name of the source, we can use the equal command. We are not obliged to use the like, as when we do not know the exact source. So equal Microsoft Windows sysmon operational and just limit to one set of commands to see what we will receive. Okay, we have an output showing, and the question asks to focus on only event ID with a specific order by date time, and it should be the first. So not to make a mistake to select the last. We should pay attention to the ascending or descending order and limit the output to only one entry. So let's change a bit the previous query and select event ID from WinEvent log data table where source equals to mentioned and order by date time. Okay, and we type the order date time limit 1 to see what we will get with this command, and we got the event ID is 16. So that's the answer to the last question, what is the sysmon event ID, but just double check. with the ascending and descending ordering of the results. So if we order by ascending, we receive as an event ID 16. Let's select all from win event log data where source equals to the mentioned and order by date time ascending limit 1. We wait a bit and we here see one subset of available commands and see as the date time what is mentioned here. And if we use the query with the descending order, we should receive not the first event but the last event. It suits the rest of the query. So we expect we expect to see a more recent date than the one in previous query from 2021 year. And we here in the output see we get a more recent date from this year 2022 as the date time. And the correct answer focuses on the query with the ascending order. Task 10 conclusion. This was a higher level overview of Osquery. I will expect you to read the whole instructions of these tasks. Elk and Splunk can ingest Osquery logs. The repo on enterprise threat hunting with Osquery and MITRE ATT and CK is definitely worth your attention. So let's check that resource. No answers needed. And we have here a GitHub tail seller, Osquery attack, Windows, Linux, ATT and CK mapping for Windows and Linux, and notes. If you enjoyed this walkthrough, please like and subscribe. Until next time.